So hi everyone. I have to say this is my first time I came to this congress, and I have to say I'm so glad that I'm here. It was a bumpy road, but at the end I made it. So what you're going to hear today is somewhat a cyber talk, but you know, usually when we hear a cyber talk, we are going to cyber congresses or papers. We are hearing that wow, our state is so bad, and you know, everyone is leaving the congress with the attitude that we are doomed. Therefore, I hopefully this is not going to be the case today. So just a really few words about myself. I'm today, as you heard, CTO and co-founder of Armo. So in other words, an entrepreneur in the Kubernetes security space. I came from the world of offensive security for many years. Then I went to the good side, and today I'm making cyber products for 10+ years. So what we're going to talk to, the base of the talk you're hearing today is a research we've done at Armo. Armo has started open source project called Kubescape, which is actually a Kubernetes security posture management tool. It is today part of the CNCF sandbox program, and this tool enables you to do a few things. One is to tell you what is the posture of your security posture of your Kubernetes cluster. It also tells you if your, I would say, how your pre-deployment configurations are in your CI/CD, so you can detect different security aspects of your deployments even before it gets to a live cluster. It also scans images in the cluster for vulnerabilities. The well-known CVEs, you've heard about it today. And the place where we are taking this open source project is to enable not just to get a bunch of data, but also to get prioritized information so you can make decisions. So beyond that, Armo, our company, is taking part of this data and stores it for our customers. This means that we have a lot of data in our systems at Armo. And we thought, well, this is really nice. Okay, we get some kind of a picture of the Kubernetes security posture of the world, and let's turn this information into something interesting for the community, something we can learn of. So this is what we are going to do today. We're going to talk about the data we collected, and we created different interesting things around that. And especially, even before we are going a little bit more into that, one of the major things we wanted to look at is how the global general sample of all the things we are seeing in the world are comparing to open source projects, which is, all of us are here because of that. So, as I told you before, we have two data streams into our platform. One is coming from the configuration side of the Kubernetes clusters. The second is coming from the vulnerability of the container images. And just to give you just a feeling of how much data we have in our systems, you can see that I think that today we are closing into seeing 20K Kubernetes clusters. I can also say that we are closing into 100 million Kubernetes objects. We've scanned 50,000 container images and so on. So we've seen a lot of data and a lot of how people are using their clusters and have a distinct view of how their security is. So returning to what I said before, what we are going to do today is we're going to look into the general population of how their security fares, and we're going to compare it into open source projects. Now, it is not easy to point out in our database how what is an open source project and what is not. Therefore, we chose to work with graduated projects and CNCF graduated projects because we said that they are the representatives of the open source world. Why? Because I think, as we all know, they are the most developed from the quality perspective, and if we want to look for differences in between the general population and the open source population, they are going to be a good representatives to do that. So the way we worked, we are starting with the data on the Kubernetes configuration. For Kubernetes configuration, we're going to work with what we call controls. Kubescape calls controls distinct tests it does on different objects and configuration files. For example, if we are looking at workload, different accesses the workload has to on the Kubernetes node, whether it has a mounted volume or it has the container is running with privileges and so on. These are the things. Each of those things are a control, a test for ourselves. So in our world, if we are taking, for example, in this case, the first control, we are looking at is whether containers are running as root or not root. You can see that in the general sample, 91% of the containers are running as root. Not very surprising, anyone who knows how containers technologies came to be. And among the graduated project sample, it's 84. So it seems that there is a slight, advantage to the graduated project, but I myself would love to see much more graduated projects are deciding to do a little work and depart from the root containers. By the way, just a question, because we are among security professionals. Anyone can tell me why is it important that the container not to have root privileges? It's a trick question, by the way. Michael? But it's not root, it's a containerized root. It doesn't have access to other parts of the computer. Root in your container is still root to some extent. Yeah, you? Mounted files, you can create mounted file. If you have mounted file, you can set the permissions on the file, and it mounts inside of you, and then I've seen this being used to privilege escalate outside of the container. So one of the directions you're telling is right. So one of the problems with the file system, anything is mounted, and beyond that is a problem, because if someone is escaping the container or has something mount, it will have the root access to the files. The other thing is that from kernel exploit point of view, anyone who's trying to exploit the kernel, it's much more easier most of the time, depending on the specific problem, but much more easy for the attacker to work with the root process and escalating from there to the kernel than an average process. So a root attacker can also overwrite the program that's being run. Or the libraries on the okay, interesting. I would need to think of that. Not clear for me, but everything. But yeah, I think that a non-root might also doing that. But you're right. Also, there might be another file system issue here. This is the first thing. The second thing is another setting for the container, which is whether a container is running on an immutable file system, meaning that only the root file system of the container, whether it's read-only or not. A question of how big problem this is from a security perspective. I do believe that most of the time containerized applications work in a way that they don't need to touch too many directories. It should be working. It should be easy to configure. Having said that, you can see that neither the general population nor the graduated projects are excelling from this part. By the way, when we are going to, I don't have a slide about that, but by the end of these slides, I'm going to tell you something we are going to release within a month, which helps with this. Another thing, in Kubernetes, when you run a pod, the pod containers automatically gets the mapping of the service account token. service account token is used to talk to the Kubernetes API server. This is the way that the containers authenticate itself. Most likely that if I'm taking random, like 100 random containers, maybe 2 or 3 of them will really need that. Most of the containers doesn't need that because they are application containers and they don't need to talk to the Kubernetes API server. Anyhow, the default in Kubernetes that they are mounted. In the graduated project sample, we saw that this is disabled around 70% of the time. In the general sample, it's 81%. Again, slight advantage to graduated project. Security contacts, there are different, this is a CIS requirement that limiting the container configuring the security context to apply a non-root user ID, apply a seccomp profile, configuring the security context of the container. Graduated projects, 81% are configuring this. In the general sample, 77% of them. So if we're taking all the controls together and wanted to spare you all the controls we went through, we created this number of trying to calculate how many of the resources are failing these controls. And among the general sample, it was 38% of all the objects, not just workload objects. And in the graduated project sample, it was 35, not a big difference. After researching a little bit more deeper in the data, we got to the conclusion there are simply too many objects which are not really have like RBAC objects and service objects and different kind of objects which don't really have effect on the security posture. That this is why they are so these two numbers are so close, despite that you've seen that other numbers were more further from each other. So the interesting thing is that what we started to do, we started to evolve this research. And we started to add that beyond only looking at the configuration side of the Kubernetes applications, what we are deploying in Kubernetes, we also started to use eBPF to identify the actuality of whether the application requires all these things, all these configurations. So just if I'm going back just for a sec to here, it is very easy with eBPF going after the file access of the container and see whether it touches the service account token. If it doesn't touch the service account token, it means that the application doesn't need the service account token. It can be safely unmounted without breaking the app. Hopefully, next time if I get accepted to the next talk, I will be able to share with you more actual information about that. So turning to the other side, not Kubernetes configuration, but actually the image vulnerabilities inside the applications deployed in the clusters we are seeing. So again, what we're going to do, we are going to compare these two samples. We're going to look at not just what kind of CVEs we are seeing, but we are going to try to understand whether these CVEs can be exploited. And I'm going to tell you a little bit later why. And I will show you how we got to our conclusions. So in the general sample, when we saw so many repositories in different clusters, you can see that even among the top 10 repositories of the general sample, that you can identify at least, I don't know, half of them are CNCF projects themselves. If we're looking at the CNCF projects from a sample point of view, you can see that there are a lot of well-known names, Kubernetes itself, Kubernetes components, ArgoCD, Prometheus, and so on. These were the list of the top image we've seen in different places. And we did a breakdown of severities of per image. What is the general outcome? So if we're taking taking a random image, what's going to be in theory the outcome of how many medium level vulnerabilities we are going to see, how many critical vulnerabilities we are going to see. And we saw that the breakdown between those are a little bit different. We can see that among, for example, if you look at the graduated sample, and I think one of the interesting things was that there is a higher chance in a graduated sample to have critical vulnerabilities, which is, again, this is not quantitative. This is more an outcome if we have an image, whether we have what is going to be the number breakdown of vulnerabilities. So this is not really normalized. But you will see that, that this brought us to the next step, okay, of looking at the top vulnerabilities we've seen in the samples. So in the general population, you can see that there was an outstanding CVE in the busy box, which was really, you know, I don't want to say tainted our sample, but it was like a really high, more than double of the next one. And we're going to talk in a minute about that, but you can see that, that there are these different kind of vulnerabilities, libgcrypt, SQLite, encurses, different kind of vulnerabilities we've seen in our top 10. So let's have a look at the first one. So, and I love this description, but I don't know, I love usually CV descriptions, how useless they are sometimes. But BusyBox allows, you know, an attacker to run an arbitrary code if netstat is receiving a malicious DNS record. And this enables the attacker, first of all, to control the process of the netstat. The second is it also enables the attacker to change the colors of the terminal, which is kind of, again, this is kind of funny if you're thinking of the descriptions. So if we're looking at this vulnerability, and again, we are trying to understand how relevant this is to a cloud native environment. First of all, there are a lot of containers who are actually running netstat to read DNS records. Even if so, the DNS record needs to go through, for example, in Kubernetes, through core DNS, and so on. So it's kind of understandable that the probability that this is going to be something that is actively exploited in a cloud-native application is somewhat low. So okay, we said, okay, this is by far the highest number of images we've seen with this vulnerability. Okay, let's go to the second. So the second was libgcrypt. Again, for me, it was quite understandable from the beginning why libgcrypt is in every container. Anyone? What's the purpose of libgcrypt in container images? For package managers, yeah. Signatures for package managers. So again, how many package managers are running actually during the runtime of a deployment? So I've seen a few, okay, but let's say that from, okay, I'm not continuing this train of thought, but I wanted to say something, but it's not right. But in general, this is again, this shouldn't be happening that much. Also, SQLite might be, again, we would think out of the box of, okay, SQLite is used by so many applications, it can be so much relevant, but again, then we remember that, I think RPM, yeah, RPM is using it to store the installation database. This means that automatically the reason why we are seeing that it's so prevalent in so many images is not because the applications are using it, but because it's part of the base images. So again, we hit something. And then, I've took these top 10 and tried to filter out all those which I think that are most likely not really exploitable, and this is my personal opinion, and only got to 2 out of 10. Okay, well, let's see what's happening in graduated projects. So we can see again that there is this CVE, which is quite an old, and we can see that a huge, relatively big amount of images are affected. All the others are Golang and Prometheus and so on. So let's go a little bit to this. after some understanding, it looked really strange that we have this old CVE in so many graduated project images. It turns out that actually it is a bug in Sifed. So it mismanages the entry, and it identifies protobuf as the C protobuf project instead of the Golang protobuf buffer, and therefore it says that it is vulnerable to everyone.
Because it relies on the CVE, and the CVE, you can have like FTP, the Linux application, you can have the FTP normal, it's the same CVE. So
Yeah.
It's a problem for right?
Yeah, so and actually there is an issue we opened on this, and it turned out there was already another issue open. So it's a saga with Sifed guys. We're working at it. So again, removing from the list those things which we think that it's really hard to exploit actively on cloud native application. We are left with a few. Now, if we're looking at, again, we're returning to the graph, and we are saying, okay, let's take an average image, see how many vulnerabilities we have here. We can see that the graduated sample has, like, for example, less than 1 critical, somewhat around 3, 4 high, and so on and so on. You can see that the general sample is like exploding. Like, there is a huge difference between those, the graduated projects and the general sample. And, you know, we got to this state when we did the research and said, wow, okay, we are like so happy. Like, we have such a good, like, quality here that we can be relaxed. But then okay, we said, okay, something has to be, you know, researching data is always, you know, asking the questions, okay, whether you are like on the right track to understand what actually is happening. And said, okay, again, returning the same question. So a CV doesn't mean that this is something that that there is an active exploitable vulnerability in your workload. And we started to think, made us think, okay, what can we do to understand this information better? And as you heard already, okay, we are in the theme of, we are jumping on the hype of eBPF, like eBPF is solving all of our problems. But I have to tell you that it's pretty cool sometimes. By the way, we can also should have a talk about how dangerous eBPF is from a security perspective, but that's another thing. Let's talk about the good things today. So what we did, we created under a new node agent in the Kubescape project. What it does, it monitors the file activity inside containers in a Kubernetes cluster. It creates a list of what files are touched during the runtime of the container. And after a time, it says, okay, I've seen enough. Creates this list of files, okay, files actually used by the container, takes the SBOM of the same container and creates a filtered SBOM based on the understanding that which software packages were actually touched by the container during the runtime. And, you know, surprise, surprise, there are few. So just, you know, giving you a small understanding, you can see that, and I'm sorry for like this, I know that this is not very successful, but like see here, Elasticsearch, how many actual runtime vulnerabilities we see as opposed to how many of them if you are just statically scanning the image. Zookeeper, you know, the funny part, see MySQL, okay, simply in the latest release we haven't found nearly any vulnerabilities which were running in the memory, but there were a lot in the base image. Postgres. So there is a big difference in the number of vulnerabilities which are actually running in the container as opposed to the vulnerabilities that, you know, found by a static scanner. So we started to correct, you know, I'm telling you, we couldn't run all the images, but we tried to create a statistical sample and compare the runtime vulnerabilities we found in the images, the graduated projects against the general sample. And as you can see, there is still, graduated projects are still much better than the general population, but the discrepancy is not that big as before. So they are much closer to each other. And we said, okay, for now we are stopping here because this somewhat makes sense to us. It makes sense to us because still graduated projects are, I don't know if is there any other graduated project who's not written in Go today? I don't know. So Go, it's much more easier to write, sorry?
Tough, I think.
Maybe, yeah. But if we're looking at, we understand that there are other like effects to this whole ecosystem in Go, because it's not just Go is a safer language, but if you're looking at how the mechanics of image scanners and vulnerability scanners are working, you understand that's why it's easier to create images which seem to have less vulnerabilities by default. Again, I'm not saying which vulnerabilities can be exploited. I'm saying that what seems to have. And obviously, I can say that CNCF does invest, and tech security does invest in reviewing projects from a security perspective, and I think it has a tremendous help to all projects. We at Cubescape also enjoyed much of the help we got from CNCF, so there is obviously an uphill. To understand why the general population is so bad, I think that again, I can reiterate what you most likely already know, that the way the whole Docker ecosystem was built, and today we are inherited in even beyond Docker the same way. In order to create a directory inside the container during the build, you already have to pull in so many vulnerabilities in that container that it makes really hard. It's not just a security problem; it's also bloating, storages and so on. So it's just simply, we have to deal within the ecosystem. So again, just recapping, the general picture. I think that in the vulnerability scanning side, we must move into a place when we start to incorporate runtime information. Simply without that, it is really hard to maintain and manage things, and even with the initiative about Google we heard today, which was like we love, we have to combine these things together to get a better picture of what we have today. From the misconfiguration perspective, there is a long way to go, limiting what containers can do and optimizing least privileges in Kubernetes clusters, which are really important if we want to protect the clusters. So that's all. If anyone has a question, yeah.
So you have all this data of what vulnerabilities you've scanned, and like what I get you're doing the scanning and like comparing what's running versus what's not. Have you taken any of this data and compared it against CISA's list of known exploited vulnerabilities to see?
So, Kev, you mean EV?
Is that what it is? Sure.
Yeah, so, yeah, sorry. Yeah. So I know two things that, there are two things, two directions we've sold lately. One is Quay EV, the known exploited vulnerabilities. It is from the cloud native ecosystem. We ran it, and it turned out that only 1 out of 5,000 vulnerabilities were in that database, which is kind of makes me think that there are some coverage issues here, because otherwise it doesn't really make sense. But yeah, by the way, we are going to incorporate that. And also the other is the EPSS, if I recall, that's the other initiative. We compared it with EPSS. I can tell you that EPSS is not a binary score. It's like something ranging from 0 to 1, and if I recall, I don't remember. I can, after catch me and I can show you. But I think that we were, if under the 10th percentile, we had something around the 10th of the percentile of the vulnerabilities. So something around it. But I can, if you're interested, I can look for it because we have the data about that.
The other question that I have is, there was a talk at B-Sides Las Vegas, I think. Actually, Yoda might have given it. Yeah, there he is. About containers, when you'd scan them, the scanning technology would not detect, like if you're scanning the container from MySQL, it wouldn't detect that MySQL was inside of that container because it had been built specifically for that container and not installed by a
package manager.
The package manager or whatever. Did you deal with that problem in your data collection?
So yeah, you caught me. So the thing is, this data represents different versions of Cypht creating the SBOM. And Cypht, anyone who's following like also Sneak, but also Trivy, also Cypht and Encore, sees that they are making huge strides lately, detecting executable files which weren't installed by the package manager. So in that sense, our data is somewhat tainted because in some of the places it was in a version which is able to detect, and some of the places it didn't.
Yeah, quick question. Great presentation, by the way. You talked about monitoring execution of the containers to see. Do you have any idea of like what percentage of coverage of the applications you're getting of the container? I mean, do you know, did the application run through like 30% of its code, or because it might trigger some of these vulnerabilities through interesting corner cases in.
So sorry, I'm going to move here because. So there are, it really depends on how the container was built. There are containers where we see only like out of all the packages like if you have 1,000 packages, we only see like 10 packages which are actually used in runtime. And there are containers where like the coverage, the container is, again, I'm not, I didn't came here to represent Go, but again, if there is a statically compiled Go executable in a Scratch image, like, yeah, you will have 1 out of 1. So yeah, it would be interesting again to not just from the CV perspective, but from the SBOM perspective to create these numbers. But again, I think that mostly all of us are understanding what is the direction, what would we get, because we'd see so many containers where most of the packages are not used. Yeah.
We probably do 2 more questions.
You don't have to.
I was just curious if you, and you may already have, but if you have talked to CNCF about what you saw and shared with them your report, I think it would be interesting to talk to their.
Michael is here. He's here.
Okay.
Yeah. Awesome. Yeah. So we had with much less data, but we already had some early data back in January, where there's the Cloud Native Security Con in Seattle. And there I shared already partial results. But yeah, I think that yeah, sure. So again, we can we can catch a presentation in one of the meetings in tax security and pull it up. Thank you very much.